Differentiation, the chain rule. To differentiate this, well, you have some function of x inside the brackets, and I'm going to use the substitution that u is equal to, and I've just made up that letter there, I could have used something else other than x or y, but u is equal to 3x squared plus 2x, and if u is equal to 3x squared plus 2x, then y is equal to u to the power of 5. Y is equal to u to the power of 5. And then you differentiate both of these. This one's u in terms of x. So this will be du by dx. And this one's y in terms of u. So this will be dy by du. 5u to the power of 4. Now, the chain rule is what we're going to use next, and the chain rule connects derivatives together, and we have three derivatives here. We have dy by dx, which is what we're trying to work out. We have du by dx and dy by du, and what you'll see in the chain rule is that these two multiply together to give this one. So we have dy by dx is equal to dy by du times du by dx. This thing is called the chain rule. We're chaining these derivatives together. Okay, so we have dy by dx is equal to dy by du, which is 5u to the power of 4, times du by dx, which is 6x plus 2. And I should put this in brackets. Now, the original equation here is just y in terms of x, and there's no mention of u in there. U was something that we've introduced ourselves as a substitution, and now we need to undo this. So this u here, we need to replace this with 3x squared plus 2x. So then we've got dy by dx is equal to 5 brackets, and then our 3x squared plus 2x instead of the u, instead of that u there, times 6x plus 2. And then this can be simplified slightly. This is all to the power of 4. So I'm going to multiply the 5 with the 6x plus 2 to get 30x plus 10 times the 3x squared plus 2x to the power of 4. Okay, so that's what dy by dx is equal to. Now this time I'm going to differentiate the same equation here again, but I'm going to use a standard result, which comes from this. If y is equal to any function of x raised to a power, so this part here inside the brackets is this part here inside the brackets, then dy by dx is given by this formula here. So applying this to this, we have dy by dx is equal to, so this dy by dx is this, it's equal to n, which is 5, times the derivative of what's inside the brackets, that inside function there. So differentiating this times this is the function inside the brackets to the power of n minus 1. So the function inside the brackets, and remember you're not differentiating here, it's just f of x. That was f dash, this is just f of x. To the power of n minus 1, n is 5, so n minus 1, 4. And then just multiplying here. Remember to put brackets around this, and then we have this. And as you can see, this is quicker and easier than doing all of this. This formula here is a direct result of the chain rule. Now you don't need to know where this formula comes from, but if you're interested, then just watch the rest of this video. Okay, so starting with this, y is equal to some function of x inside the brackets raised to a power. If I use a substitution here, so u is equal to f of x, so I'm going to substitute this part here, like I did in the previous example, the bit inside the brackets. Then y is equal to, because that's u, so that's now u to the power of n, and then differentiating both of these, so this one will give us du by dx is equal to f dash x, because that's what you get in function notation once you've differentiated. And differentiating this, that's y in terms of u, so then using the chain rule, dy by dx is equal to dy by du times du by dx, and all we're doing is just multiplying these two derivatives together. So dy by dx is equal to dy by du, which is n u to the power of n minus 1, times du by dx, which is this. And now we have to undo the substitution. So to get rid of u and go back to something in terms of x, well, u is equal to f of x. So then I've got n, replacing the u with f of x. So it's all of that to the power of n minus 1, and this is where I'm going to use some brackets here, put n minus 1 times f dash x, and then rewriting everything as n f dash x times f of x to the power of n minus 1. And this is exactly the same as this. So as you can see, if you start with y is equal to any function of x, all raised to a power, you can use this standard result to differentiate. And this result comes from the chain rule as we've seen here.